Thank you very much, Frank. So thank you all for being here today. It's great to have this opportunity to chat with you before the Build conference gets fully underway tomorrow. So the thing that I wanted to chat about is, like, thematically this idea of the agentic web, which I'm guessing a bunch of you have been thinking about. Like, I certainly spend most of my time in my role as CTO thinking about how all of the pieces have to come together in a very complicated AI software ecosystem to allow people to build things that fully utilize the capability and promise of some of these advanced AI systems we've been building over the past handful of years. But I thought before we get into like a bunch of jabber about architecture, that we could start a little bit with a review of the past 12 months. And like one of the things that I like to do at Build every year, and like I'll do a little bit more of this tomorrow, is to like try to make some predictions about the 12 months ahead. And I think the thing that we can all see is like making those predictions even 12 months in advance, which isn't a huge time horizon by normal standards, are incredibly difficult to do. So one of the big things that happened over the past 12 years that I think caught a whole bunch of people by surprise is the advent of these reasoning models and all of the things that reasoning inside of these advanced AI models unlock. So we have things like Copilot Researcher, things like deep research in ChatGPT that can do just incredible, extraordinary things. And I'll talk a little bit about one of my core beliefs around AI right now, which is that we have this thing that I've been calling the capability overhang, where I think for a whole bunch of use cases, we're no longer necessarily reasoning constrained in the AI applications that we built. And in fact, there are just a ton of opportunities to have a higher ambition for the reasoning component of the agentic software that we're building. One of the things that's probably obvious to all of you who are developers here in the room is roughly aligned with the development of these reasoning models, is that coding model improvements and software engineering agents and copilots have gotten extraordinarily good over the past year. So if you look at some of these metrics like 𝗦𝗽𝗲𝗀𝗀𝗃 that are measuring the percent of tasks that are the model or the agent is able to solve for developers, like it's just been extraordinary progress over the past year. And the things that Frank talked about a minute ago, him building his Bob Dylan random quote generator, or just the constant stream of anecdotes that I hear from everyone, from developers who are doing cutting edge things on big complicated distributed systems, to people inside of Microsoft Research trying to push the frontier of software engineering and algorithm development, all the way to what I see kids doing in high school who have no prior programming experience at all. Like all of that interesting activity is happening just because we've had a real incredible set of breakthroughs over the past 12 months in these coding models. And like I think the breakthroughs will continue over the coming year. I thought it might be interesting, though, rather than me talking just about the progress from my point of view, to go out and have a conversation with a bunch of people who are working on the frontier of AI. So I spent a few minutes chatting with folks who have spent a lot of time over the years thinking about AI and who are playing leading roles in pushing this frontier forward for all of us. So let's take a minute and watch this video.
It's almost too exciting of a time. It's so wild.
The past year, we've seen many surprising and order of magnitude jumps.
Since, 2018 or so, where I said, man, this looks to me like an exponential. It's going to be completely wild and wilder every year.
It's been 2 years away for the last 15 years. And now it finally works, and there are robots that will drive you around San Francisco, and it's magical.
Reasoning that definitely took the spotlight. The one family of models matching or even exceeding human level performance.
I'd definitely be amiss if I didn't point to the reasoning models, hybrid reasoning models, where, starting in Claude Sonnet 3.7, and it's like, oh, this model, you can turn reasoning on or off, and you can tell the model how long to think in terms of its reasoning.
One of the cool things about 𝗦𝗲 is it can use all the tools that you're used to using with GPT-4, but it can use them as it's thinking. It can write Python code to understand an image if you ask a question about an image, and can search, take the results, reason about them, search again, to fill in gaps, and this kind of iterative thinking process is very human.
It's a little more like a human, right? You don't have one brain that answers right away and another brain that, decides, oh, I should, scribble some stuff on paper and think about this for an hour. I put these things together.
Deep research for the first time was a qualitative change for me. Having the deep research agent go off and do work for 25 minutes, and it's coming back with a 20-page document spelling out something hugely complex that you just, it's not that it's saving me a little bit of time, it's that I would have never been able to do that on my own.
The individual agent thing will just get better and better. Meeting transcripts and your messages, the way it'll help you out will be pretty profound.
I think we will see models that generate synthetic problems, grade themselves, and bootstrap reasoning without using any new internet data.
In Africa, there's this unbelievable shortage of doctors. And so the open-mindedness to create a kind of personal doctor that you have over the course of your life, we're driving forward on that because it's the only way that you're going to get the health coverage to be super strong.
A great, scientific researcher paired with 𝗦𝗲, I think really will accelerate the pace of scientific research.
It's how do you fit a great teacher with the great AI, or how do you connect to all the health information, in every local dialect in the world. I think the next 12 months will be pretty stunning.
We're in the process of building machines that are going to be able to make sense of it in a way that humans cannot. We've already seen that with things like AlphaFold, but I think that's the beginning. I think before this is through, we're going to have 100 AlphaFolds, and that's going to be amazing.
The day that AI can propose this novel scientific hypotheses that are recognized as correct and non-obvious, we'll have crossed a different threshold.
I think there's a democratization aspect too. If you go back and look at history, every time we have enabled more people to create in different ways, good things happen.
My advice is there are a lot of people who are in the category of, I don't know, I tried these models a year ago and I have a sense of what they're capable of and what they're not capable of. Don't look away, don't blink.
That's the goal, right? If you're not embarrassed by where you were 12 months ago, then you're not moving fast enough.
Yeah, so this is super good stuff from a bunch of our friends and collaborators and colleagues. The thing that I would encourage you all to do is to think about the past 12 months and what has been surprising or eye-opening to you. Like one of the things that I will share is I've got two daughters, an 8th grader and a 10th grader. And my 10th grader has an internship at the Cardiothoracic Research Lab at Stanford, where she does, bad things to rats in service of science. And my daughter's working on this project that her PI assigned her, which is figure out how to build a more accurate blood oxygen saturation meter. And so like normal, blood pulse oximeters, like take infrared readings from your finger, they're super inaccurate. The highly accurate pulse oximeters require arterial blood draws and are super slow. And if you're a heart surgeon, trying to make, moment-to-moment decisions when you've got a patient's chest open, you really need accurate data and you need it very, very quickly. And so she's working on this medical device, and at some point you're building a medical device, you've got to write code. My daughter could not have less interest in coding, despite my efforts to get her enthused about it. But she's got to the point where like she has to like do something. She doesn't have money to go hire her own developer, and so I start getting these questions. She texts me one night and has it's like, "Dad, what's a CNN?" And I'm like, "Why do you want to know, child?" And she explains the problem that she's trying to solve. She needs to segment out these retinal photographs and to like get just the blood vessel pixels out of these images so that she can perform some other calculation. And I'm thinking to myself, I'm in the car coming back from dinner, like I don't have time to do this research myself. My intuition is that it's like slightly the wrong technique to solve the problem. She doesn't have enough training data to train a CNN. There's probably not one that's been a convolutional neural network, by the way. There probably isn't one that's pre-trained for this problem. She probably should be using classical image processing techniques. So rather than going off and doing a ton of research myself, like I would have done when I was a grad student, I just asked deep research how to solve the problem. And I ask it very specifically like how it would solve the problem, and I ask it to write the code for it. And it asked one round of clarifying questions and then sent a complete solution back with 27 citations, including a bunch of medical literature where this problem had already been solved and a working bunch of Python code. And the share button in the app let me send it to my daughter. When I was in my 20s in grad school, having studied computer science for like a whole bunch of years, including taking an image processing course at some point, like that would have been a couple of days worth of solid work for me, and like this AI system had solved it in 4 minutes. And like the point of that story is that like there are these extraordinary things happening all the time because the capabilities of these systems are increasing. And an even more extraordinary thing that's happening, which is you have people like my 16-year-old who only know a world where you can ask an AI how to help you solve these complicated problems that all of us probably have some preconceived notion are too difficult for us to go tackle, and then she gets the problem sorted out. And like the unlock that will come from that over the next handful of years, I really do think is going to be just absolutely extraordinary. So the thing that I wanted to chat with you all about now is just sort of this rate of agentic software adoption. So if you look at what's relatively visible about agentic software adoption, we've increased the number of daily active users across the entire ecosystem of agents in Microsoft and out by about 215% over the past year. So we have this really tremendous growth rate, not just of the capabilities of systems, but how people are using them in their daily life to do real work. But still, we are not really leveraging the full potential of these AI systems. And it's why I wanted to chat with you all today, and why one of the big themes of the Build conference is going to be around this idea of the agentic web. We likely aren't nearly as reasoning constrained as we have been in the past, but like there's a bunch of stuff in this ecosystem that has to get built out so that agents can more fully deliver what it is we hope that they can deliver. And like that, what that is you want agents to be able to delegate work to, and you want the work that you're delegating to these agents to be increasingly complicated over time, like help me sort out an image processing problem for my medical device, or I don't know whether that Bob Dylan app's all that hard, Frank. Sorry, but we want to solve everyone's problems, like no matter where they're at, because the thing you want is like human imagination to be as unconstrained as humanly possible. So in order for this vision of like these really powerful agents coming into existence, like they have to do some things that they can't do right now, and like those things largely are not about reasoning. So the reasoning will continue to improve, like we've just are going to continue to see great progress there. Like the things that I'm seeing right now from our partners and the things that we're building here at Microsoft are just stunning. So like you all will not be disappointed by the rate of progress on the reasoning frontier. But there are a handful of new things that have to start happening pretty quickly in order for agents to like be the recipients of more complicated work. So we sort of think about this runtime layer that sits below agents, and like there's some really important pieces in this runtime that need real work, and we'll talk about some of this at Build, and we've got some announcements to make. And like some of these problems are going to get solved out in the open, like in the open source community, because like the important thing about them isn't that Microsoft's opinion gets expressed or some big tech company's opinion gets expressed, or like we've won some kind of technical argument. Some of these things only matter when they're ubiquitous, and so it kind of doesn't matter like which approach you choose, just as long as you get to the thing that's really ubiquitous as quickly as humanly possible. So one of the things that is like quite conspicuously missing right now in agents is memory. And because of this lack of memory, most of what we're building feels very transactional. So you interact with an agent, maybe it recalls past interactions, like probably doesn't. It almost certainly doesn't remember like its scratch work over time, like the way that we would. Like we solve a problem once and like we sort of write it down somewhere on a piece of paper or store it on disk, or we remember it. So memory is one of these problems that is really going to be important for us to solve, and it needs to be a form of agentic memory that probably more mirrors what happens with biological memory. So biological memory is like a funky thing because it actually isn't like a database at all. It's very, very imprecise, but we have a set of cognitive tools that we use to have large recall, so that when we're trying to have a recollection about something, like we can refine the recollection across a huge amount of information. And we can refine the precision of the recall using a whole bunch of tools, so that like when we've slightly misremembered something, like we can get to a more precise recollection. And ultimately, like we do need our agents to have precise and broad recollection of past interactions with us and with the information that they process over time, the solutions that they have previously made to problems. And there are a bunch of super cool things that we are doing right now to address some of these challenges. So part of the challenge that we have right now is like it's difficult to give an agent full context given a prompt. Like the prompt sizes or the context windows are limited now. Like the fundamental computer science about expanding context length is kind of funky. Like there are a whole bunch of things in there that are quadratic. So like you can have longer context, but it gets really expensive the bigger the context windows are. And like we've got biological clues that tell us that that's probably not the way that like a real, sort of reasoning sort of memory works. We have fragmentation, like, information that we have available to agents is distributed across a whole bunch of different stores of knowledge and memories. And we have these precision and recall problems where, sometimes agents hallucinate, sometimes, because of this context or fragmentation problem, like you don't even have the information available to the agent so that it can do recall, and like it isn't iterative in the refinement of these memories and can't get to, what's missing. And so, some of the fun things that we are doing that we'll announce and we'll have a GitHub repo for are things like structured RAG, where it's, I don't know whether you all, like I'm old, or old enough, where, I remember these memory exercises they would give us in school when we were a kid. And like this is like a core part of how you train a biological brain. Like you sort of don't brute force everything in your head every time you need to solve a particular problem. You don't like go from first principles and just grind it out every time. You have like a whole bunch of cognitive things that you learn that we figured out over time that help us be more precise in recall for memory. And so structured RAG is one of those biologically inspired techniques where we are imposing structure on top of context to help have more precise recollections for models so that memory can get better and so that you can reason over larger volumes of information. I've already said all of this good stuff. And this is the GitHub repo. This is live right now, so you all can go check this out and start playing around with it. One of the other, one of the other problems or set of problems that we'll have to solve with memory is, it opens new problems when you have agents that have perfect recall and have perfect recall over every interaction that they've ever made. So context really is going to matter. Like you will have these, things where you likely are going to have a personal agent and you're going to have a work agent, and like the work agent is going to like have a whole bunch of your employer's information in it that is like yours and the employer's. And so like we're going to have to really think hard about, like, for these enterprise scenarios to make agents really useful, like how you're going to deal with memory entitlements. Like how do you make sure that the agent has access to everything it needs to have access to, and like IT doesn't lock the whole thing down and like make the agent have some weird kind of amnesia because they're paranoid about where information's going. And the systems here also have to be developers first. Like we can't have these super complicated systems. Like you all should go check out structured RAG. Like tell us whether you think the code's good or not. One of the reasons why we're trying to do a bunch of this stuff out in the open is like I think simple is going to win here. And like we've thought really hard about how to make the basic principles here as simple as humanly possible so that people can jump in and help us or like help the entire world refine where we're going. So the other thing that's really interesting and conspicuously missing in the agentic web is, like, we've sort of talked and you heard from the people in the video mention the fact that like the reasoning model helps you do planning. So you have this reasoning capability, which means that you can sort of chain together like a bunch of complicated actions, which is awesome. And like I think those capabilities will get better and better over the coming year. But one of the things that's really hampering the ability of agents to fully leverage that planning capability is like we don't have enough of the universe wired up in a way where agents can access those things. And this is where these protocols that are emerging are really super interesting. So you all have probably heard about MCP and A2A. Like MCP in particular, we're very, very excited about, and it has it's filling such a unbelievably big need in the ecosystem that the adoption of it, like even though what Anthropic put out early is like a really, really super simple implementation, is like really kind of breathtaking. And so, the way that I've been thinking about the agentic web and these protocols is it's a little bit like the unrolling of the sort of emergence of the web back in the 90s. So some of these things like have very similar equivalences to the web. So MCP is kind of like HTTP. It is a protocol where you can connect to a service or someone who's got a piece of content they want to make agent accessible. The protocol itself doesn't have a whole bunch of opinions about what ought to be in the payload. It's super simple, like it's easy to implement. Like the structure of it is going to make it easy to amend over time, to like layer things on top of it so that you can solve other problems where you don't have to throw the whole stack away every time you like need to make a minor tweak. And all of those are like super, super important to getting to ubiquity, because like that's the important thing here. Like in order for agents to be as useful as they could be, like they need to be able to sort of talk to like everything in the world. It's also important, by the way, I think ideologically as well, because if you imagine like this sort of counterfactual scenario of what would have happened with the World Wide Web if you picked a player in the ecosystem, like say the browser makers, and the browser makers had decided like we want to like control everything in this ecosystem, and so like we have to have a bunch of vertically integrated protocols, and like and like our imagination is going to be the imagination that decides everything that's going to be the web. like obviously, 20, 30 years of hindsight tell us that that probably would have been a very uninteresting or less interesting version of the web than the one that we have right now. And so the important thing about the openness of these protocols and simplicity and trying to get to ubiquity as quickly as possible is that it means that like your imagination gets to drive what the agentic web becomes, like not just a handful of companies that happen to like see some of these problems first. So yeah, like I talked a little bit about the capability overhang a minute ago. Like I think it's kind of an obvious thing at this point. The thing that we have observed over and over again, and like Bill hinted at this in his part of his video interview, we already have extremely useful things that agents are capable of, like medical diagnosis, for instance, that are not available to literally billions of people in the world who do not have access at all to any kind of quality of medical diagnosis. And so, like, it is just fact right now that models are more capable than what they're being used for. And like part of our job as developers, like you all in the room and developer advocates and journalists and people who are writing and thinking about all of this stuff, is to try to figure out for those like really urgent problems that we collectively have, how can we help solve this capability overhang? Like you got a ton of space for innovation, and like we're seeing it, many of you here in the room today who are like entrepreneurs and building new companies, like, man, I'm just seeing some extraordinary stuff happening at extraordinary speeds. So anyway, it's like going to be a really, really interesting time. Like the thing that I will say, like for the developers in the room, is like there are a handful of anti-patterns here with the capability overhang. Dario mentioned one of these, with his advice to folks. I hear these all the time, by the way, from Microsoft developers when they will sort of look at a system. They say, like this is right on the margin, like the quality of what's coming out of the model isn't quite good enough to solve this problem. GitHub Copilot, by the way, was one of those things. Like when we first showed this to people inside of Microsoft, they looked at the system, which at the time was at about a 30% accept rate, I think, for code for developers accepting the code that came from a coding prompt that was given to GPT-3. And some people saw that and they were like, oh, this is horrible, 30% is nowhere near good enough. And some people saw that and were like, holy crap, this works at all? Like, oh my God, like what's the trend line look on this? And like that's how things like GitHub Copilot happen. And so like, I think you all have to really set your product ambition to 11. Like you've got to really sort of be targeting things that actually seem impossible to you. And you really do have to like ignore the marginal cost. Like this is one of the things that's been so true over the past 6 years. Like we're getting about 10x cheaper price performance wise on inference every year. Like I wish I was 25 years old again, because like all I had was Moore's Law, and it's a piece of crap compared to what's happening right now. So you really, really should never be telling yourself that this is too expensive to do, because stuff is getting cheaper so faster. So I'm over my time. So we already showed you type agent. Okay, sorry. So let me just sort of close by saying that the last time that I was as excited about being a software developer or a technologist as I am now was in the 90s. And one of the reasons why is I had this kid in a candy store set of building blocks that even a dummy like me could get my head fully wrapped around. I could understand how each of these individual pieces worked, and I understood how they composed, and I could just go play. And I could play because all of that stuff was permissionless. Like there was no gatekeeper sitting there telling me, you cannot do this. Because you have to sign a BD deal with us, or you have to like get reviewed in this particular way or whatnot. And so that's the moment you all are in right now. Like all of these building blocks are available to you. they're relatively simple. Like I'm watching people do just nutty stuff. Like my last story I will tell before I stop ruining Frank's show is, you know, I went to, this again features my 16-year-old, who, by the way, is not a programmer or a developer. I went to this review that they were doing of their end-of-year social entrepreneurship projects at our school. And I knew she was doing something to try to, like, help, you know, kids who were on hormone blockers, like, do calcium supplementation. Like, you know, how do you get, like, a teenager to, like, to do anything that they don't want to do? And, like, I show up to this thing, and, like, she demonstrates this app, and I'm like, the hell did you write an app? It's like, you don't know how to program. And, like, moreover, like, you never came to Dad and said, like, hey, like, I'd like some help with this app. Like, not a word. And so what had happened is they had spent about an hour and a half with one of the dads from their school who taught them how to use one of these AI app development systems. And these three girls who are not programmers and who don't particularly like the idea of programming, built an app that any of us in this room who were, like, active developers in 2008, when you could write your first mobile application, would have been super proud of this thing if we had built it ourselves back then. And, like, that's the moment we're in. Like, they didn't have to ask anybody's permission for anything. There was nothing too complicated about the building blocks for them to understand. They just went and did something cool. And, like, that's our challenge to all of you at Build. Like, we're going to give you a ton of tools to go work with, and then we hope you go do something cool with it. Thank you very much. Frank.